Hey guys, I'm going to take a look at formula number 3 in kinematics. So we'll call this kinematics formula 3. Okay, so what we're doing here is we're looking at formula number 3. I'm going to solve out a couple examples, and we'll go from there. So again, this is a handy dandy sheet to have around because it does tell you when solving for displacement or distance in a direction, use these formulas: initial velocity, final velocity, acceleration, and time. So this is just a matter of using algebra skills to solve for problems. So the third formula goes like this. Final velocity squared is initial velocity squared plus 2 times the acceleration times the displacement. All right, so if there's a question that asks for like the final velocity of something during a period of time of acceleration, and we're given the initial velocity, and we're given the acceleration, and we're given the displacement, we can go and solve for what the final velocity is. So like conceptually, I might ask a question like, how fast does a jet travel at the end of its acceleration? If it starts at 0 and it accelerates at 45 meters a second squared for, let's say, 5,000 meters, what is the velocity of this thing? So like, I might also like call it like, what's the final speed? Velocity and speed, they are interchangeable in one circumstance, and that is when you're looking at speed as being a speed with a direction. All right, so let's do that. My question will be, what is the final velocity of a jet? Okay, you might want to draw a picture of an airplane flying along. What's the final velocity of an airplane? And I'll actually get rid of that square. That's our question mark, and I'm going to give you an initial velocity of 0, and I'm going to give you an acceleration of 35 meters per second squared, and I'm going to give you a distance or displacement of, let's say, 5,000 meters. So we're looking what the final velocity is of a plane that starts out at rest, accelerates for a distance or displacement. So this is a matter of just taking this formula and writing it for what we need to write it for. So here's our formula. Vf squared is v naught squared, that's initial velocity, plus 2ax. So to get Vf squared by itself, Vf, we're going to square root the whole thing. So Vf, square root of a square, you just get rid of that, is Vo squared plus 2ax. Now if you look at your formulas, your formula card here, I have velocity final is the square root of velocity initial plus 2ax. That's your displacement. So you can look at your formula sheet, or you can solve it for the formula here using number 3. So let's go ahead and do it. Let's solve for it. So velocity final is our initial velocity of 0 plus 2 times our acceleration times the displacement of 5,000 meters. So it's just a little tip. If you're not really too comfortable with the calculator, that's okay. You're going to get comfortable with it. But what you want to do is you want to just solve for this stuff first. So 0 squared is 0. You're going to take 2 times 35, and then you're going to multiply it by 5,000. And under the radical, Okay, what I ended up getting was like a big number, like 350,000. And don't stress the units because they do work out according to the equation we have. Okay, and then I just take the square root of that number and I end up with like 590, about 592 meters a second. Okay, so what I did was I solved for the final velocity. Okay, this takes practice, guys. It's not something that'll come very easy to you. Definitely takes practice. You got to learn to use these formulas and to find the right ones you need. So we ended up saying initial velocity times 2, and then A acceleration was 35. This just means that it speeds up at 35 meters per second every second. So like the first second it's going 35 meters a second. The second, you're adding another one of those, so it's 70. The third second, adding another one. So it's just speeding up here. That's all that's telling you. Okay, so that's how to solve for final velocity there. We're going to solve for the other variables in this equation. Hi guys, so we're going to take a look at something that asks for the initial velocity of a situation. So let's look at a whale. Okay, so draw a picture of a whale. Okay, whale's here. Okay, this whale, as our picture here, is moving along. Okay, we don't know what the initial velocity is. Okay, but we do know what the final velocity, we know how far he's gone, and his acceleration. Okay, so let's do this. I don't know the initial velocity. Let's say the final velocity of this whale was 20 meters a second. Okay, 20 meters per second. And let's say the acceleration of the whale was 2.5 meters per second squared. So it's sped up every second at a rate of 2.5 meters per second. Okay, let's say it covered a displacement in this time of 300 meters. Okay, we want to know what the initial velocity of the whale is. Okay, now here's where we start getting into some not issues, but it's almost I think beneficial in physics for you just to have that formula ready. So you're looking for initial velocity, and I did find from you guys the other day that you preferred to use this formula sheet here. So look, what I found was initial velocity formula. When I have XAT, well, let's see, XAVF, no. VFAT, nope. VFAX, VFAX, I got it. I don't know if you can see that there, but I've got it. So what I've done is I've taken this formula, this wonderful kinematics formula, and I've solved it already for you, solving for initial velocity. VF squared minus 2AX. Okay, so this is where this starts to become very useful. Okay, velocity initial is, let's do underneath the radical, VF squared. Let's leave the units out to make it simpler. We know it's going to work out based on the formula. Minus 2. Acceleration is 2.5. Okay, and then X is 300. Okay, so let's see how this works out. Maybe this whale started out going the other direction. Who knows? Maybe a current was bringing it backwards. If we get a negative number for this velocity, then that tells us that the whale was moving in a different direction. Let's check. So I do 20 squared. So under the radical, I've got 400. And then minus all this stuff. Okay, 400 minus 1100 gives you the square root of can you have a square root of a negative? The answer is no, you can't. So the deal is that the initial velocity was definitely some velocity in the backward direction. So this will not work. Okay, so this gave us a number that was too big on this side of the equation. So the initial velocity was in the negative direction, and we're going to start with a velocity that's either 0 or in the positive direction. So let's change this number here to something that, so here's a rule. You're not going to be able to, there are no negatives under radicals. Okay, so the answer to this is you'll have like 5 different choices or 4 different choices. Can't be solved in this situation. Can't be solved because 300 meters, it cannot cover 300 meters in this amount of time. So this is this would be a tricky type of question, but let's make it more realistic. And let me change just a couple variables here. So the takeaway is you can't have a negative radical, so this doesn't work. Okay, so let's look at our whale question again. Okay, we got a whale here. Okay, it's moving. Vf squared is v naught squared plus 2ax. Okay, where we're looking for the initial velocity. Okay, so we'll say the final velocity is 20 meters a second. Let's say the acceleration is 2.5 meters a second squared. And let's change that displacement to 30 meters instead and see what kind of initial velocity I come up with. In this case, I'm going to look at it as we're not going to get a negative sign underneath that radical, which would cause us some problems. Okay, so again, looking at our initial velocity formula, I ended up using VFA and X, VFA and X. So I used this one. So initial velocity is the this final velocity squared minus 2ax. So velocity is Vf squared, which is 20 squared, minus 2. A is 2.5, and then x is 30. Okay, so now we're looking like it's gonna work out okay. So 20 squared was 400. 2 times 2.5 is 5. Times 30 is 150. Okay, so velocity initial, is this 400 number minus 150. So it's a square root of 250. Okay, velocity initial. Okay, if we just find out what that is in the calculator, square root of 250. So square root of 250 is 15.8 meters per second. Okay, so this works. Okay, this gives us a good check mark. Our 300 number originally didn't work because we had a negative underneath the radical. Didn't work. So that was a good example of something that you may have that it gives you some numbers, and one of the answers is cannot be solved. In this case, the initial velocity of this thing was 15.8 meters per second. So during this time, or in displacement, the velocity ended up going from 15.8 meters a second to 20 meters a second, given an acceleration of 2.5 meters a second squared and a displacement of 30 meters. Okay, so let's look at another rendition of it. This is still formula number 3. Vf squared is V naught squared plus 2ax. Now we solved for this already. We solved for this. Now we're going to look at acceleration next. Okay, so let's look at what the acceleration of a car is. So here's our car. Okay, we need to know how quickly it's accelerating. Let's actually flip it in reverse. Okay, let's say the car's accelerating negatively, but starts out with a positive velocity. I'm going to say that again. The car has a negative acceleration, but yet it starts out with a positive velocity. So that just means it's slowing down. Okay, so let's give it an initial velocity. Let's say the initial velocity is 25 meters a second. Let's say the final velocity, let's go down to like 5 meters a second. Let's give it a displacement of 50 meters. So now, since we started out more than we ended, we're going to come up with a negative number for acceleration, and that's okay. Okay, so that just means that this thing was cruising along at 25 meters a second. Okay, and then something stopped it, like the brakes, and made it slow down to 5 meters a second. Okay, so this is the direction of the velocity. This velocity, it's positive. It's still going to go positive, but this is being slowed down by an acceleration of something. We don't know what it is. So let's look at our cards here. Okay, again, this takes practice, ladies and gentlemen. It's not just going to come very easy to you. You've got a lot of information here, and you're going to need to take some time, and I'm going to give you some time in class to do some of these problems. Okay, so I have VO, initial velocity. I have initial velocity, final velocity, and displacement. And I'm looking for A. So here's your acceleration formula. I've got initial, this is VF, VO, and T. Nope. X, VO, and T. Nope. VF, VO, and X. VF, VO, and X. There it is. So our rendition of this formula is this one. I just changed it around. It's going to be A is VF squared minus V naught squared over 2x. Okay, so let's do this out. VF squared is 5 minus 25 squared over 2 times 50. Okay, let's do some of the math here. Do the top and then the bottom. 5 squared is 25 minus, okay, I believe 25 is squared is 625. Yeah, so 625, that's this, all over 2 times 50, which is 100. Okay, so let's go through and figure this out. Acceleration is 600 negative, so you subtract these, negative 600 over 100. So the acceleration ends up being negative 6 meters per second squared. Okay, so it's slowing down at a rate of negative 6 meters per second squared. Okay, and that's how you get that. You may want to pause this to write this down and then to look at it again when you're doing the work. Important to take the notes as well. Okay, we're getting into the final stretches of this last formula. This is again number 3 still. VF squared is V naught squared plus 2AX. Okay, So we did this, we did this, we did this, and now we're going to look for how far. Okay, so let's just look at like a little fish friend. Okay, here's a little fish friend here. Little fish friend starts out at some initial velocity, makes it to some final velocity. It accelerates. We don't know how far it goes. Okay, in that acceleration. So we want to know, okay, we're actually looking for like x, how far it goes. So let's give it some initial velocity. Okay, let's say it's 2 meters a second. Okay, and then let's give it some final velocity. Let's just say it goes to 2 to like 2.5 meters a second. So it's not really going to accelerate that much. Okay, let's give it an acceleration of 2 meters per second squared. Okay, that's 2 meters per second every second. So we're going to find x. Okay, we've got the rest of the variables that we're looking for. And so I'm going to come up here and I'm going to say, all right, I have a formula for displacement which says VO, VF, and A. I'm looking over here, I got displacement formulas, VF, VO, and A. That looks like the one I'm going to choose. So let's do that. I'm going to choose that formula. Okay, so it's x equals VF squared minus V naught squared over 2A. Now all I did was I just rearranged that formula to solve for x. Okay, and I'm saving you guys that step. So x equals VF squared, VO squared over 2A. Okay, sometimes I write things twice. All right, so x is VF squared. That's 2.5 squared minus 2 squared over 2 times the acceleration. I'm just plugging and chugging here, basically. So what we have is 2.5 squared. Okay, this is 6.25 minus 4. That's 6.25. That's the 4 over 4. So 6.25 minus 4. So on the top, I've got 2.25 over 4. Okay, x is 0.56 meters. Okay, so it's gone 0.56 meters. Okay, and that's the displacement. This thing is gone, given the fact that it started this, went to this, and accelerated at that. So you might want to pause that for a second and write it down, and that's it for the that's it for our formulas in kinematics.